Hello and welcome to this lesson about more difficult mixture problems. The learning target for this video is setting up and solving more advanced mixture problems. So more difficult, more advanced. What do I mean by these things? So there's a couple of things that we might be doing. One, when we look at maybe like the inputs that we're going to be using, the mixture of solutions, they may be sort of, the quantity might not be known. So an unknown quantity, meaning that we're going to have to use a trick to kind of figure out how to set up an equation. The other thing that can make it more advanced is we might have to do a remove and replace. Now fortunately, what's going to help us is still our magic box. And I'm going to make it a little bit bigger here now. Okay, so we're still going to cut it in half like that. And then what we're going to do is actually kind of break it up into about fourths. And what we're going to do is put the line right here. So we'll still have A, we'll still have B, but what we might have, is a minus A. So that's if we're doing a remove and replace. And then over here on the right hand side, we'll still have the whole A plus B thing. And likewise, we'll still have a percentage or maybe a dollar sign depending on the context. And then down here, we will have the amount, or vice versa. I mean, the order in which you do that doesn't matter. Remember, this is an organizational chart to help us cook up the equation. So with that being said, let's take a look at some examples. So this one is, how much of a 30% solution needs to be mixed with a 70% solution to form 20 quarts of a 40% solution? And so this is case number one, where we have this ambiguous quantity thing going on here. We're going to take 70% plus 30%, and the things we have no idea about how much, but we know it's going to equal, when it's all said and done, 20 quarts of a 40% solution. So to help us solve this, we're going to use what I like to call the ribbon trick. Because what we know is that A plus B, if we're looking at just at the quantities, that has to equal 20. So one of these will be X, and then the other one is going to be 20 minus X. Okay, and so it doesn't matter which way you set it up, but you do have to remember which one X is. So let me write that down because that's kind of important. Remember which one X is. You'll see why when I explain it in a minute. Anywho, let's make our magic box. And I think to be more consistent with how I did it in the first video, amount, percent, A, B, and then we got that hard line there, A plus B. All right, so the amount, we don't know for either one, but what I'm just going to say is for the first one, I'll let it be X. So the second one has to be 20 minus X. Percentages, 70 or 0.7 and 30, 0.3. But what I do know is that the resulting mixture is 20 times 0.40. Now I make my equation by multiplying these two rows together. So I will have 0.70x and then plus, now here's where it gets a little tricky, 0.30 times 20 minus x is equal to 0.4 times 20. Now I'm going to suggest that you take your time and you write it out, because we have a distribution problem. And one thing I've seen over the years is that many people make mistakes, myself included, and sometimes forget to distribute to that second term over here. So just make sure you're taking your time. So we have 70 or 0.7x plus, and then 0.3 times 20 is going to be 6 minus 0.3x is equal to 0.4 times 5, which is 2. Okay. We are, oops, sorry, no, 0.4 times 20, which is 8. That doesn't make sense. There we go. That's 8. Okay, now get all the numbers on one side and all the variables on the other. So I'm going to subtract 6 from both sides. And now here I got to combine some like terms. So I'll get 0.4x is equal to, and then 8 minus 6, 2. Finally, divide by 0.2, or sorry, 0.4. Let me erase that. 4, 0.4, 2 divided by 0.4, and then x equals 5. Now, back to what I said. Remember which one x is. X is 70%. So that means that we're going to need 5 quarts of 70% solution. And then if we're going for a total of 20, the remaining 15 quarts will need to be 30%. And again, this is very similar to what we were doing earlier, but the difference now is that we don't have known quantities here. We have to use the ribbon trick. Now let's take a look at another example. A 16-quart radiator contains a 50% solution of antifreeze. How much needs to be drained out and replaced with pure antifreeze to obtain a 60% solution? All right, so we have a little bit of reading that we need to do, pure. So we have to remember that means 100%. And what we have is a remove, replace problem. So remove and replace. And with problems like this, we're going to use a slightly different magic box. We're going to use a bigger box. So notice how I'm trying to make it a little bit bigger. Now on this side we still will have that hard line and we'll have A plus B. The order in which you do the other side doesn't matter all that much. It just matters that it's there. So I'm thinking we'll probably just go with A and B, but then A plus B, and then we're going to go minus, A. And so this represents, actually let's do this a different color. This represents what's being removed, and then B is the replacement. All right, so let's read the problem and see what we have. 16-quart radiator contains 50% solution of antifreeze. So let me pick a color. Let's go light blue. Amount, percentage, 50% antifreeze. Now we're going to replace it with pure antifreeze. So that's going to be 1 or 100%. So what will become 1 in a minute. But we don't know how much we're replacing it or how much we're adding. So it's going to be X. Now here's the thing. We're removing and we're replacing. There's 16 quarts. We're draining some of it out and then we're filling it back up to 16. What that means is that these, in this case at least, and in most cases, are going to have to be the same. X. Now what we're going to notice is that these down here are going to be different. And they better be, right? Otherwise we've done absolutely nothing. We're removing 50% because that's what's currently in there. And so we should have some nice parity between these two. These guys should be the same if we're removing and replacing. And then the goal is to obtain a 60% solution, which is that right there. So 60% solution. And the amount, we have to, again, do some reading. This is a 16-quart radiator, and we're filling it back up to the top. It didn't get any bigger. It didn't get any smaller. It's still a 16-quart container, so 16. All right, same idea. We're going to bring these two rows together, make an equation, and solve it. So I will get 16 times 0.50 for 50% plus 1x, so 100%, 1x, minus, now keep in mind that's going to be a minus here, 0.5 or 50x is equal to 16 times 0.60. All right, so let's crunch some numbers. So we have 8 plus, and then 1 minus 0.5 is 0.5x is equal to 16 times 60, or 0.6. That's going to be 9.6. So you got to combine some like terms, or actually not combine like terms. In this case, we're subtracting the 8. So So 0.5x is equal to 1.6. So 1.6 divided by 0.5, that gives us, 0.5, 0.5, x equals 3.2. And so 3.2 represents how much we are draining and replacing. So 3.2 quarts. We'll box it, we walk away. All right, so again, same sort of mechanism, same strategy, same tool. The big difference is with some of the problems, we might use the ribbon trick like we do right here. In some of the other problems, we're going to have to add a whole nother column, and then we got to pay attention to what goes in there. There's some similarities. So these are going to match up because you're draining and replacing, and then these are going to match up because of that whole remove, replace idea. So good luck with your homework or practice, and let me know if you have any questions.